At this point, we've seen insert, append, delete for a circular doubly linked list with a sentinel. Okay. So what's left to do is random access and find. Find says, please find me something in the list, wherever it is, and random access says, get me to the ith element in the list. So let's do those. We're going to write the Python functions for those. Those obviously belong to the Sentinel DLL class. And then last part of this lecture is going to be the full-blown runtime complexity for comparing it to lists. All right, so let's do find. Same as before, I have a doubly linked list. It's circular, and I have the sentinel here. Okay. And find, again, is a member function of the doubly linked list class, and I'm looking for some data. Okay, so if these were strings, it would be find me Maine, find me Idaho, find me Utah. Okay. So first thing I'm going to do is, and this is a little weird, so bear with me for a minute and I'll explain why I'm doing it this way. I'm going to place the data I'm looking for into the Sentinel's data cell. Okay? So that may seem like a strange thing to do, but let me give you the motivation for it. When you have a circular list, there is no real end, right? You can keep following next pointers over and over again. And obviously you know that this is the first element and the last element of the list because of the none here. But by doing this, there's a clever little trick down below when I'm looking for the data. So I'm going to just start by putting the data right in here. Okay, that's what I'm looking for. Now, I'm going to start searching after the first node. Remember, this is the Sentinel. This doesn't store any data except I just shove something in there temporarily, but obviously we're eventually going to take that out. So x is equal to self.firstNode. Remember what first node does? It returns the first data node in the doubly linked list. So while x.data does not equal data, so what am I going to do? I'm going to ask, is data stored here? So if it's not, I'm going to keep looking. And if it is, then I'm going to pop down. Okay? So while x.data, the node I'm looking at, does not equal data, then x equals x.next. Okay, go to the next node, come back up into the while loop and check. Go to the next node, check the data. Go to the next node, check the data. Okay, now, if we find it, we of course break out of the while loop and then we continue here. And if we don't find it, what's going to happen is, well, x.next still works on a circular linked list, so I'm going to come to the sentinel. And at this point, this while loop is guaranteed to finish. So notice something a little clever here. This is why I put the data in here. I have a single check, and it does two things. It tells me if I found the data in one of the cells, and simultaneously, it tells me if I've looped around because I took the data that I was looking for and I shoved it into the sentinel. So this is just a clever little trick that I can look for the data and have a stopping condition all in one by this little trick of putting the data into this sentinel. So one way or another, I'm going to stop when I find data. Either I found it in the list or I found it back in the sentinel. Now, of course, I have to distinguish between those two things. All right, so let's deal with that. So first things first, before we forget, let's go back and fix the sentinel. So self.sentinel.data is equal to none. I'm going to annihilate that temporary data that I put in there and return it to none. And now I have a decision to make. Did I find the data in the list, or did I simply hit the stopping condition? Which one of those is it? Well, this is easy to find out. X, remember, is the node where I stopped outside of the while loop. And if X is equal to the sentinel, well, then I looped all the way around and I return none. You didn't find it. And if that's not the case, well, then I just return the node because that's where I found it, either in this position, this position, this position, or this position. Okay? So just a clever little trick. I didn't have to do it this way. I could have had two stopping conditions. I could have said, well, x.data does not equal data and you have not reached around to the sentinel, but this is a cute little trick to just sort of tighten up that code a little bit. All right, last thing, let's do random access. Remember what random access is find me the kth element in the list. So this is 0, 1, 2, 3, or if you wanted to, this could be 1, 2, 3, but let's just index on 0 because that's how lists are indexed in Python. So again, random access is a member function of the DLL class. I'm taking a single variable, which is k, an integer between 0 and the length of the list. Now, k may be greater than the length of the list. I don't know, so we're going to have to deal with that somewhere. That what if I ask for the 100th element of a list that only has 4 elements in it? We're going to want to deal with that, obviously. But if there is the 4th element in it, well, then I just simply want to return that node. All right, so here we go. Set the counter to be 0. Obviously, we're going to count as we make our way down the list. Set x again to be the first node. So that's going to be a counter 0. Now, while counter is less than k, so what is this doing? Is I'm going to start counting, and as long as I don't get past k, I'm going to keep going. And I'm going to make sure that I haven't looped around to the sentinel. So here I'm double checking now. So this is that double check that I told you about that we avoided in the find example. So while counter is less than k and x doesn't equal sentinel, x equals x dot next, and increment the counter. So what am I doing? I'm saying, okay, this is 0, 1, 2, 3, and then if I loop around here, then I stop, or if I hit the kth element, I stop. And then, same game. If I hit the sentinel, that is if x is equal to the sentinel, then I return none. You are asking for an element that doesn't exist. Otherwise, return the kth element, which you found, which is just x, because you've incremented over. Okay? So both of these sort of operate in the same way. They have to index through. And here, you can see the cost of a doubly linked list. We're going to formalize that in a little bit, but here's the intuition, is that I've got to loop through both random access and find. And with find, you can forgive it. You got to find something in a list. That's going to be the same cost whether you have a list or a doubly linked list. But in a doubly linked list, random access is expensive because there is no notion of the kth element in order. Everything is very loosely attached, giving us a lot of power for adding and deleting, but there's a cost down the line. Okay, in the last segment, I'm going to just sort of bundle up all the runtime complexities for list and for linked lists and for doubly linked lists, and then we'll say the last few words, and that'll be it for this lecture. So I'll see you in a few minutes.